Hey everyone, it's Kira Garfolo with Greenville Tech Math 155 again, and today we're going to talk about percent of difference, which is section 3.2. So sometimes it doesn't make sense to talk about the plain difference between two numbers, okay? Think about this practically. If I tell you that something increased by $10, well, a $10 increase in your rent is a lot different than me saying your order at Taco Bell increased by $10, right? Price of a meal is a lot smaller to begin with. Your price of rent is higher to begin with. So that $10 relatively is very different. Same concept. If I say, congratulations, you got a raise of $10,000 per year, that's likely that it's going to matter a lot more to one of us than it is to somebody that's making, $275,000 a year. Relatively speaking, $10,000 is a lot more to somebody making less. So instead of comparing that raw number, that absolute difference, we are going to rely on something called relative difference. And in this case, we're going to consider the difference between the two quantities, and then we're going to divide by the reference quantity, which is going to be picked as one of the quantities. And most often, we're going to give this as a percent. So instead of just relative difference, we're talking about the percent of difference. Okay, so we're going to look at the difference, the absolute raw difference, okay? Of course, the pen is not working again. Are you guys as amused as I am that it never works, even though I turn it on before I set record? So consider the difference between the two quantities. So this is the absolute difference or a raw difference. And then you're going to divide by a reference, okay? So a lot of times in our class, this is what we're going to do. Relative change, difference between the new amount and the previous amount. So again, that raw difference divided by our reference amount, which most commonly we're going to use as the previous amount, okay? If we're talking about something changing. If we're talking about what it changed from, then the previous amount is going to be our reference. So what it changed from. And sometimes that's intuitive and sometimes it's not. We'll see some examples today. This fraction by itself is going to give you a decimal. If you want to do it as a percent, remember that you're just going to multiply it times 100 to get that 100, that version of percent. So for example, let's say that the temperature has risen from 40 degrees to 60 degrees. So it started at 40, coming from 40, and it ended at 60. Okay, so what is the percent increase? Well, remember, we're going to look at the difference and we're going to divide by that previous. So the difference here is that 60 minus 40. So we had a 20-degree difference, and our reference is what it started at, which is 40 degrees. This is going to give us 0.5, so we had a 50% increase in the temperature, okay? So our temperature increased by 50%. Now, what if it drops from 60 to 40? Now, what is the percent decrease? We want to be careful here, okay? The from is our reference. It might be tempting to say, oh, well, it was 50% before, it changed 20, now it's still going to be 50%, and it's not, because our reference value is different. We still have 20 on our numerator, okay? That's going to be the same, but now we have 60 as our denominator. So now the percent decrease was 33%, okay? Be careful. Don't fall into that temptation of assuming that it's going to be the same each time, because it won't. Your denominator changes. Let's get a little bit of practice. The temperature is going to rise from 70 degrees to 85 degrees. What is our percent of increase? So we know from 70 means that we are going to have 70 on the bottom, okay? Because that's going to be our reference. Our temperature difference, it went from 70 to 85, so that's going to be 15. We can say our new minus our old divided by our old. That's kind of how I learned it, okay? So new minus old over old, if you're talking about something changing over time. So now it's 85, it was 70, and we're going to compare that to what it was at 70. And if we plug this into our calculator, we're going to see that this is 21.4%. You can plug this into your calculator all at once. Remember to use your math print for your fraction, or put these in parentheses up top. Okay, so a 21.4% increase. Okay, this would be a great place to pause and get some practice. I'll move ahead though. By what percent is a class of 25 students larger than a class of 10 students? So this one, pay close attention, okay? We don't have a from, we're not changing over time. But what is our reference here? Our reference is going to be the one that has than in it, okay? Because that is our reference. We're comparing it to there. It's larger than this comparison, okay? So our comparison then is going to be that 10. And we see that 25 and 10 are 15 apart, but we can do the math here. Okay. And if we turn this into a percent, it's going to give us 150%. Okay. So that class of 25 is 150% larger than a class of 10. And you can think about it intuitively, make some math in your head to see why that's true. If the profit of a company decreased from 7,500 to 5,500 per year, what is the percent of decrease? So again, from, when you're looking for reference, you're going to look for keywords. You're going to look for from. You might see than, and sometimes there are some other words, but these are the most common. So from 7,500, so let's go ahead and put 7,500 on the bottom, to 5,500. Okay, so if we want to do that old minus new, or new minus old, we know that we had 5,500 minus 7,500. Or you can do it in your head and say, oh, well, it's a $2,000 shift. Okay, doing it just like this is going to give us a negative. Okay, we're going to get negative 26.7%. Don't worry about the negative. Okay, that negative simply tells us it decreased. Okay, so you could say the change is negative 26.7%, or you can say it decreased 26.7%, because that decrease tells us it's negative. Okay, so you can kind of see how that works. There are some words of caution here, and I've kind of alluded to them as we've gone, but you want to be very careful with your verbiage. And while intuition is very helpful here, a lot of times we can intuitively think through these. Sometimes it can lead us astray. And in this example that I'm about to show you is where even I still struggle if I don't think carefully and mathematically, because my intuition kind of leads me astray. Doubling and tripling, quadrupling, and so on can cause some issues here, okay? So if a quantity becomes 4 times its original size, by what percent did it increase? This is where we want to think in terms of real numbers, okay? Pick something like 1 and 4. Pick something, you know, you say, oh, if something becomes 4 times its original size, maybe it started at 20 and now it's going to be 80. No matter what you pick, as long as you've done the math for that part correctly, you'll get the right answer here, okay? It might be tempting here to say, well, if it's 4 times its original size, 400% is the answer. And yes, it is now 400% of its original size, but that's not the question. You want to know what percent it increased, okay? Because it was already at 100%. That's where it starts. So it did not increase by 400%. We're actually going to see that it increased by 300%, okay? So you could think about in real numbers. Say, okay, well, it started at 1. And now 4 times would give us 4, okay? So our reference is where it started. So it's going to be that 1. And our new minus old is going to be 4 minus 1. So we're going to get 3, which is 300%, okay? Think carefully about this. You don't have to use 4 and 1. You could just as easily say that you started with 20. Okay, so 4 times is going to be 4 times 20, which is going to be 80. You can use these. 80 minus 20 over 20 is going to give us 60 over 20, which is going to still give us 300%. So don't get hung up on why I chose 1 and 4 here. Those are probably the easiest to start with 1, right? But start with whatever you want. As long as you do this math carefully, you'll be good. What if a quantity becomes only 1/3 of its original size? What did it decrease? Well, now instead of saying you started at 1, you could say you started at 1 and you ended up with 1/3, but now you've got some ugly fractions to deal with in math, right? So now you can say, well, I'm going to start at 3, and I'm going to end with 1/3 of that, so I'm going to end with 1. Remember that the start at is your reference. The 3's down here. We can see that it decreased by 67%. Okay? Be careful. Again, it's not 33%, which is roughly 1/3. You have to be careful with your math here. Pick real numbers and run it through. Now, if our data is expressed as a percent, and we're talking about percent changes, this can get confusing quickly. If it doesn't confuse you to talk about it in terms of decimals or any of that, that's fine, as long as you're very careful with what you do. Do what makes the most sense intuitively to you. Typically, what I will do is think of it in percentage points, okay? So I won't say 67% is 67 over 100 and then do that math, because even in the calculator, it's easy to lose that in the order of operation. I'll just think of it in terms of percentage points. For example, if interest rates rise from 5% to 6%, then I know that the difference is 1% or 1 percentage point, okay? From 5% tells us that that's the reference. So they changed 1 percentage point over the 5 percentage points that it started at, which means that they went up 20%. They increased by 20%, okay? Okay, let's practice a couple more before we wrap up. Go ahead, pause if you need to. I'd highly recommend it. If a quantity becomes 2 times as large as it was previously, by what percent has it increased? Now, this is one of those that you're going to want to probably come up with some numbers, and be careful. It's not 200%. That's what your gut may tell you. It's what mine tells me, even still. 2 times as large as it was. Let's say that it started, what do you guys think? Let's say it started at 5. I don't know, pick any number. If it's 2 times as large, then it's going to mean that it's 10 now, okay? So our reference will be that 5, and now it's 10. So what percent has it increased? Well, now we have 10 minus 5 over that 5, which is going to give us 5 over 5, which is 100%. Okay, so it is increased by 100%. Some students struggle to understand this, but we're not talking about it's now 100% of what it started. We're saying that it increased by 100%. So if it started at 5 and then it increased by 100% of 5, that means it increased by 5 more, which sure enough gave us 10. Okay, so do the math carefully here. What about Bob here? Bob's test score increased from 70% to 90%. By what percent did his grade increase? Okay, be careful here. It's not 20%, 70% to 90%. As a statistician, this is one of my pet peeves when I read articles, because that's not a 20% change, okay? It's a raw change of 20% points, but it's not a 20% change in the score. Here, let's just say he got a 70 and he got a 90. It's from the 70, so that's going to be our reference. And we know that now he has a 90 minus a 70, so the new minus the old. So it's going to give us 20 over 70, or you can plug that directly into the calculator, and that's going to give us about 28.6%. So his grade increased by 28.6% of 70, okay? Yes, that is a 20 percentage point increase, but we're not talking about the raw difference, we're talking about the relative difference. So everything we're doing built on that first section, right? we're looking at the ratio of change to the original. So we're still dealing with ratios. We're still dealing with proportions if you kind of think carefully about it. Be very careful with your reference value, okay? You're looking for some keywords. Look for from, look for than, okay? You're looking for the original, what it started as. You want to think in terms of real numbers if no actual values are given. So those problems that are doubling and tripling or quadrupling, make sure that you set some sort of number up, okay? Start with 1, start with 10, start with whatever makes the most sense, but use those real numbers. When you're dealing with those data as percents, like test scores, just drop the percent, okay? 70, yeah, he got a 70% on the test, say he got a 70, he got a 90. That's going to help you keep all of these percents from overlapping. Practice, practice, practice. Where are you going to practice? Look in your textbook. During each section, which hopefully you are reading, you're going to see some worked examples, okay? At the end of each section, there are lots of practice problems, and the solutions to those are also included. So there's some great work for you right there. Remember that there are additional resources in Blackboard. Remember the Math Center is available, and always, always, always remember that I'm available too. Thanks for listening, and I will see you for the next section.